Hello, good day everyone. Welcome to my learning channel, Sir Fox Learning Channel. At kung bago ka sa channel na ito, huwag mong kalimutang mag-subscribe at i-hit ang notification bell para updated ka sa mga susunod ko pong video. Today, I would like to present to you rock cycle. And hopefully, this video will help you, especially sa ating mga distance learners who are taking Earth and Life Science. Makatulong po sana ito sa inyo para sa inyong pag-aaral, especially sa ating self-learning modules. Happy learning, everyone! Okay. Rocks, materials of the solid earth. In this lesson, we will show the interrelationships among the three types of rocks. Earth as a system, the rock cycle, magma as a crystallization and igneous rock, weathering, transportation, and deposition. So I will show you the interrelationship among the three types of rocks through the rock cycle. Earth as a system, the geosphere has the cycle of rocks: sediments, sedimentary rock, metamorphic rock, and magma. The processes are lithification, metamorphism, and melting. See as we go along with the discussion how it happens, how rock cycle happens through lithification, metamorphism, and melting. When lithification happens, when metamorphism happens, and when melting happens. How rock forms from igneous to sedimentary or to metamorphic rock. So I will show you in this lesson how does it form. On the screen, we have here a table showing the cycle of rock. Started from a magma in which it will form as a lava, and once the lava flow from volcanoes, usually from volcanoes, and it will crystallize. Or when magma or lava cools and crystallize and solidifies, then one type of rock is formed, which is the igneous rock. So from magma that flows out usually from volcanic eruption, and once that magma crystallized or solidifies, it forms an igneous rock. Now, igneous rock undergoes several processes as well. It can be through weathering and through heat and pressure. So once an igneous rock breaks down and transported and deposited in areas as sediments, it forms sedimentary rock. And sediments will form, and it forms sedimentary rock. So once a igneous rock uh, weathered and then breaks down in, into small pieces, usually affected by the weather through rain or shine, then later on, those particles which broken down from or smallest the small particles which breaks up or breaks down from the igneous rock deposited in a form of sediments, and later on it will be deposited in an area forming into sedimentary rock. That sediments will undergo lithification, or lithification means compacting of sediments or cemented to form sedimentary rocks. Usually, as an particles which taking from the breaks or breaking down of or weathered materials from igneous rock, once it was deposited in an area and then undergoes moist or liquid will pour on it, then it will undergo lithification, or that sediments will compacted, and then it will form to sedimentary rock. But sedimentary rock can be also formed into sediments by weathering and transportation as well. However, igneous rock also can be formed into metamorphic rock by heat and pressure, as we can show here in the table. Then this sedimentary rock can also be formed into metamorphic rock through metamorphism. So when sedimentary rock is buried deep in the crust, binaon, heat and pressure or stress or heat and pressure cause it to become metamorphic rock. So it will undergo metamorphism once a sedimentary rock will be buried. Then that rock will will affected by high pressure inside 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 the Earth's surface. That's why it will undergo metamorphism, forming into metamorphic rock. And then the metamorphic rock usually melts in once that metamorphic rock melts, it will magma will form, and that magma becomes lava again. So that's the cycle. Melting of rocks happens, of course, at the surface of the earth. Once a sample of rock will be buried for a year. This will not happen for a day, but for years actually. So the cycle will not happen for a day, but for many years or several years sometimes. So the processes: crystallization, when magma solidifies, the process is crystallization. So here is it. And then it forms into igneous rock. Igneous rock, once it weathered because of rain and shine and stress or pressure, igneous rock weathered. And that weathered materials, uh, once it's compacted or deposited in a certain area of the earth, will become it will be compacted, forming into sedimentary rock. And once a sedimentary rock be buried in the earth's surface, that sedimentary rock will melt And the process is called metamorphism, or will undergo rather stress or pressure, which forms into metamorphic rock. And the metamorphic rock, initially, since the temperature or pressure inside the surface of the earth is high, initially melt down. Okay? So the three forms of rocks are igneous rock. The first is igneous rock, forming from magma which cools and crystallizes. Usually, rocks which are formed inside the earth are called plutonic or intrusive rocks. However, rocks which form on the surface of the earth formed from lava or material similar to magma but without gas, it is called volcanic or intrusive rock. Take note the difference of igneous rock. We have intrusive igneous rock and extrusive igneous rock. Intrusive, those are igneous rock which are formed inside the surface of the earth. However, extrusive, extrude, outside, external, those are igneous rock which are formed outside the surface of the earth. Crystallization of magma. How magma crystallize? Of course, magma crystallizes when ions are arranged into orderly patterns. Crystal size is determined by the rate of cooling. Slowly rate forms large crystals. Fast rate forms microscopic crystals. Very fast rate of cooling forms glass. So that's how crystallization of magma uh, forms crystals. Classification of igneous rock is based on the rock texture and mineral constituents. Textures refers to the size and arrangement of crystals. So there are types of textures of igneous rock crystals. The fine grain, which refers to fast rate of cooling. Coarse grain, which refers to slow rate of cooling. Porphyritic, or two crystal sizes, or two rates of cooling. And the glassy, very fast rate of cooling. So here are some examples of textures of igneous rock depending on the rate of cooling. Textures of crystals depending on the rate of cooling. So you can see here on the sample of fine-grained igneous textures of crystals. Another example is the coarse-grained igneous textures. So depending on the rate of cooling, fast, moderate, and slow. Porphyritic igneous texture, that's the porphyritic igneous texture. Take note the difference. So the crystals, as the discussion stated a while ago, depends on the rate of cooling. And the glassy one, texture, looks like that. Igneous rocks, or classification of igneous rock, is based on the rock's texture and mineral constituents. Another is mineral composition. It explains, which was explained by Bowen's reaction series, in which it shows the order of mineral crystallization and then the influence by crystals settling in the magma. Here is a classification of igneous rock. Just observe the table below here. The textures, glassy, porphyritic, fine-grained, and coarse-grained, and the different given examples of the rock or classifications of igneous rock. Granite, diorite, gabbro, basalt, andesite, and rhyolite. Here is the Bowen's reaction series: high temperature to low temperature. And look what happens according to Bowen's reaction series. High temperature, what are the how crystals forms towards a low temperature rate of cooling of magma. And then types of rock will form at the right side based on the rate of cooling. Granite igneous rock composed almost entirely of light-colored silicate, quartz, and feldspar, also referred as the felsic. Feldspar and silica quartz. A high silica content, about 70%. Common rock of this is granite. This is an example of granite. Basaltic igneous rock, however, contains substantial dark silicate minerals and calcium-rich plagioclase feldspar, also referred to as mafic, magnesium, and ferrum iron. Common rock of these basaltic rocks is basalt. This is an example of basalt igneous rock. Nakita nyo na ba yan? Other compositional groups of igneous rock are andesitic or intermediate igneous rocks and ultramafic. Now, let's proceed to another type of rock is sedimentary rocks. Sedimentary rocks forms from sediments, weathered products of igneous rock. About 75% of all rock outcrops on the continents are sedimentary rocks, used to reconstruct much of Earth's history. So usually, sedimentary rocks are used by constructions of buildings. The hollow blocks are examples of sedimentary rocks. Clues to past environments, which provides information about sediment transport. Rock often contains fossils. Economic importance for sedimentary rocks: the coal, the petroleum, and natural gas, and the sources. Sedimentary rocks also the sources of iron and aluminum. Now, let's classify sedimentary rock. If igneous rock has a classification based on the rate of cooling and formation of crystals, sedimentary rocks has also classification based on the source of the material. So kanina, rate of cooling in igneous rock and formation of crystals. Here, in sedimentary rock, based on the source of materials. We have the detrital sedimentary rocks. The materials of these detrital rocks is solid particles and classified by particle size. Common rock include shale, which is most abundant, and sandstone and conglomerate. So example of detrital rocks is the shale, sandstone, and conglomerate. Let me show you the classification of sedimentary rock. The coarse, over 2 mm, medium, fine, and very fine. Sediment name, rounded particles, angular particles, or gravel. Sand, keep abundant feldspar. And then the rock name is conglomerate, breccia, sandstone, siltstone, and shale, so on and so forth. Just observe the table on the screen. Example of shade with plants fossils and sandstone and conglomerate. Another classic is an example of classification of sedimentary. Aside from the detrital rocks, these are the detrital rocks, shale, sandstone, and conglomerate. Aside from detrital rocks, the chemical rock or chemical sedimentary rocks, which was derived from material that was once in solution and precipitates to form sediment, directly precipitated as the result of physical processes or true life processes of biochemical in origin. Common chemical rocks are limestone and aggate. Limestone, the most abundant chemical rock, microcrystalline quartz, or also known as precipitated quartz, known also as chert, flint, and jasper or aggate. And then another chemical rock is evaporite such as rock salt, gypsum, and coal. Here is an example of limestone, a fossiliferous limestone. Sedimentary rocks are produced through lithification. Loose of sediments are transformed into solid rock. Lithification has two processes, compaction and cementation. By cementation, calcite and silica iron oxide are formed. Features of sedimentary rock. If igneous rock has features according to crystal size, sedimentary rocks as well has its own features. The strata or beds, most characteristics, the bedding planes, separate strata, the fossils, traces or remains of prehistoric life are the most important inclusions, which helps determine past environments used as time indicators, used for matching rocks from different places. And last type of rock is metamorphic rock. Change form rocks produced from pre-existing, from igneous or sedimentary rocks, or other metamorphic rock. So metamorphic rock can be taken from igneous, sedimentary, and metamorphic rock. Metamorphism, the process which takes place where pre-existing rock is subjected to temperatures and pressures unlike those in which it formed. So in metamorphism process, it depends on the degree of metamorphism exhibited by a certain sample of rock, texture, and mineralogy. Low grade, example of low grade metamorphism, shale becomes slate. Nagbago lang ng form from one form to another. High grade of obliteration of original features. So I think ito na yung example of rock melting into magma. High grade metamorphism. Metamorphic setting. Saan ba nagaganap yung metamorphism? Contact or thermal metamorphism occurs near a body of magma. So on the surface of the earth, changes are driven by a rise in temperature, of course. Regional metamorphism, directed pressure and high temperature during mountain building produces the greatest volume of metamorphic rock. So contact and regional metamorphic setting. Agents of metamorphism. Heat, pressure, active fluids. So heat and pressure stress from boreal of rock samples combines pressures from differential stress during mountain building. However, chemical active fluids as one of the agent of metamorphism, mainly water and other volatiles, promote recrystallization by enhancing ion migration. So here is an illustration of origin of pressure in metamorphism. Increasing of confining pressure here, confining pressure, etc., etc. Metamorphic textures. So if igneous, sedimentary has their texture, metamorphic rock has also textures, foliated texture and non-foliated textures. Foliated textures of metamorphic rocks refers to the minerals were in a parallel alignment. There is a parallel alignment. Minerals are perpendicular to the compressional force. Non-foliated metamorphic rock if it contains equidimensional crystals or resembles a coarse-grained igneous rock. So development of foliation due to direct pressure. Just look at what happened to the samples before metamorphism and after metamorphism. Common metamorphic rocks. Foliated rocks are slate and schist. Slate are fine-grained, splits easily. Schists are strongly foliated, like platy. The types are based on composition, like mica and schist. Here are some of the classification of metamorphic rock. Okay. Common metamorphic rocks are foliated rocks, genus, strong segregation of silicate minerals, banded texture, non-foliated or marble. Parent rock is limestone. This is uh, the genus typically displays a banded appearance. Marble is used as a building stone variety or of colors. Quartzite, a parent rock, quartz sandstone, which grains are fused. Here is a marble metamorphic rock. That's a marble metamorphic rock. Metallic mineral resources: gold, silver, copper, mercury, lead. Concentrations of desirable materials are produced by igneous processes and metamorphic processes. Most important ore deposits are generated from hydrothermal or hot water solutions. Hot contains met, metal-rich fluid associated with cooling magma bodies. Types of deposits include vein deposits, fractures or bedding plains, disseminated deposits which are distributed through the rock. However, non-metallic mineral resources makes use of the materials, non-metallic elements, physical or chemical properties, and two broad groups of these are building materials and industrial materials. Building materials are limestone and gypsum. However, industrial materials are fluorite and corundum, silivite. Non-metallic resources and metallic resources and energy resources.